Good morning, everybody. So we gave you guys some notes about forces the other day. We just want to make sure that you guys fully understand them, so we're going to talk about them a little bit more. So like we've talked about, force is a push or a pull on an object. We talked about that a little bit with gravity already, which we're being pulled toward the earth. So we're going to be talking about two different kinds of forces. We have a contact force, which is when objects apply a force and are touching. They are making contact with one another. So like when you're pushing your pencil onto your paper when you are writing, you are applying a contact force. When I'm holding my pencil, I'm applying a contact force. When I'm throwing a basketball or you're throwing a basketball, you are applying a contact force. Then we're also going to be looking at non-contact forces, which are when objects are applying a force and are not touching. So our example is gravity. Remember, if you're like falling, the earth's not touching you, but it's still pulling you toward it with gravity. Then there's magnetic and electrical forces. If you guys have played with magnets before and you are holding them close together, you might feel them pulling toward each other or pushing away. That's also a non-contact force. They aren't touching. Force, in addition to being a push or a pull on an object, is a vector. So a vector, the important thing to remember is a vector has a size. So it's going to be large, small, and a direction. So that means it's going in a certain direction. So we have some examples down here. We have two arrows. We represent vectors with arrows. If it's longer, it's going to be a bigger size. And then it's pointing in the direction that force is going. So this vector shows a bigger force than that one. The N is going to be newtons. That's our unit of measurement. So make sure you're writing capital N's when you're doing our work with using this unit for newtons. It's not a lowercase n, it's a capital N for newtons. Remember, it's the unit of measurement for forces. So we use different units of measurement for different things. For example, when we're measuring how tall we are, we use feet and inches. So like I'm 5 feet 6 inches. And we use like rulers for that, right? So for forces, we use newtons. And when we're going back to direction for a little bit, they can go in all sorts of directions. So we have right, left, up, down. They can even go diagonal. So that means like a force is pushing on it from the left and up. And we'll see that on the next page. Okay, so I want to look at an example because we're going to learn about what net force is. And net force is the combination of all of the forces acting on an object. So we're just going to focus on two directions for this first example. So we have a game of tug of war, and we have this side's pulling away, so they're pulling to the right. All of the vectors show to the right. And this team's pulling to the left, so they're pulling, and this is going to be a contact force because they're pulling on the rope. And then this side, we're going to add all of these together to see what the force is pulling to the left. So we have 3 newtons plus 5 newtons plus 3 more newtons. That gives us 11 newtons to the left. On our right side, we have 10 newtons plus 15 newtons plus 5 newtons. So we get 30 newtons to the right. So if we're only focusing on these two directions, you could say our net force is going to be 30 newtons minus 11 newtons, and we are going to end up with 19 newtons. But in which direction? It is going to be the direction which is bigger, so it's going to be to the right because there's more newtons pulling to the right than to the left, so it's going to be 19 newtons to the right. All right, so we're going to turn the page. You guys might have written this on the same page. It's on my next page. So this is more about calculating net force. So here we have a car, and one person's applying 100 newtons of force to the left, and then it looks like a kid is applying 50 newtons. So because they're going in the same direction and they're working together, when forces are working together, we are going to add. You're going to add the forces. So we are going to have 100 plus 150 equals 150 newtons to the left. So we have a longer vector. Down here, we have 2 kids fighting over a teddy bear. One kid's pulling 100 newtons to the right. The other kid's pulling 100 or 75 newtons to the left. So when they are working against each other, we subtract them. So 100 newtons minus 75 newtons equals 25 newtons. And because this force is larger, that means it's 25 newtons to the right. And here's an example of how we can end up with a diagonal. So we have forces pulling down. We have a force pushing to the right and a force pushing to the left. So we have 25 newtons minus 20 newtons. So that gives us 5 newtons because this side's bigger, going to the left is bigger. It's going to be 5 newtons to the left. But then we have 10 newtons going down. So the total net force is going to be the 10 newtons acting down, like the 10 newtons of gravity, plus the 5 newtons to the left. So we have 15 newtons going diagonal, or you could say southwest. So 15 newtons southwest if we use our directions. Up would be north, to the left would be west, to the right would be east, down would be south. So maybe this isn't gravity, it's just someone pushing the car down this way. 15 newtons southwest. Okay? All right.